Hello everyone, welcome back to today's class. Today we will be learning the third law of motion, class 9, chapter Force and Laws of Motion. So till now we have learned about the first law of motion, which is also known as law of inertia. Then we learned the second law of motion, which is simply denoted as force, F equal to ma, which is also known as, means from where we also got momentum of an object, which depends on the mass and the velocity of an object. Today we will see the third law of motion. So the statement, the third law of motion states that for every action there is equal and opposite reaction. That means if I am doing something like hitting an object or throwing a ball, there will be an opposite reaction experienced by me or any other object which is doing the action. For example, I have a ball, simple Costco ball. So if I drop the ball or throw the ball onto a wall, the ball will bounce back like this. The ball bounces back. In this activity, the action which I am applying is dropping the ball, and the reaction is the bouncing back of the ball, which is provided from the ground. So it can be visualized like this. This was the ball dropping, or as dropped by me. The ball hits the ground and bounces back. So the action, if you see in this activity or in this case, the action is of myself dropping the ball and it bounces back. So the action is dropping of the ball and the reaction is provided by the ground or provided by the floor, in which it bounces back or bounces up. Second, for example, I have a spring. For example, you have a rubber band or a spring. If you pull the rubber band or the spring, it tries to contract back. So the action is pulling it apart, and the reaction is when the spring or the rubber band wants to contract back. And if I pull it and leave one of the end, it will strike back at a little bit more force. So I have a rubber band. To understand, like this, I have a rubber band, stiff rubber. If I am pulling the rubber hard, it expands, and if I leave, it bounces back or retracts back, and this is the reaction. The rubber bounces back and puts an effect on my hand, on my other palm. So that is the reaction. This is the action and this is the reaction, the bouncing back of the rubber and putting force or an effect on my palm. So this is how we can understand the third law of motion. Now, the third law of motion is also known as conservation of momentum. Conservation of momentum. You can write it down. So I'm just rubbing this part. Right here. Conservation of momentum. Now, what does this line mean? First of all, momentum, we simply know momentum is the product of mass and velocity of an object, of a moving object, in simple words. So if an object is moving, the object will have a velocity, and every object has its own mass. So taking the same example of the ball, I have the ball is having some mass, and if the ball is dropping down, it is having some velocity, or if I am throwing the ball is having some velocity. So that creates the momentum of the object or of the ball. So momentum is simply denoted as P equal to mv, mass into velocity of the object. Now conservation of momentum, conservation means that the total momentum before happening of an event or an activity is equal to the total momentum at the end. So according to the conservation of momentum, there is an example or activity given in your book. So according to the activity or according to the activity which is given there are two spheres or two objects of different mass, two objects of separate mass. So we wrote momentum equal to mv, and we have two separate objects m. This is object A, mass of object A, ma, and mb of object B, mass of B, object B. So exam like that, I am taking two balls or two objects, if you say like, this is object 1 having mass ma, which is a little bit more heavier than this one. This is object B with the mass mb. Sorry. So accordingly, if both are moving in the same direction with some initial velocity, that means velocity which is at the beginning, both are moving in the same direction with same velocity and both are having different mass, so both will have a different momentum, like P equal to mv, mass is changing, so momentum will be different. So here we can take like, this is moving this side, this is moving also this side. So both are moving with the initial velocity u. For object A, initial velocity is ua. For object B, initial velocity is ub. This is the first condition. Now, as both are moving together in same direction, different mass means different object in same direction, what can happen? Both can collide. Like even if they are moving in the same direction, the momentum can be different because one is little bit more heavier than the other. So if momentum is different, so what can happen? They can collide. So if they collide, that means the velocity may be also different. So after collision, if they collide, what will happen? This will come collide with this, and this will move forward, and this will be also moving forward, but with finally with different velocities. So this is happening in the second one. Object with mass A will have some force. So for it will means object with mass A is colliding with object with mass B. Means the first one is colliding with the second one. So in this case, this object A is putting force on this one. So this is force A on B. Same way, B will also put some force, and this will be force of B on A. Second one. So first, going through this, the first one we are getting momentum. Momentum of A will be mass of A and the velocity, that is our initial velocity, u of A. Momentum B will be mass of B, u of B. This much we got the momentum, separate momentums of both A and B. In second one, what is happening? A is colliding with B. That means A is putting some force on B. Force of A. Okay? Which is going on to B. If A is putting force on B, B will be also putting some force back on A. because it validates our third law of motion. For every action there is equal and opposite reaction. So if this one is going and hitting this one, it will also try to put some force on it. It will try to stop this one. So this is validating our third law of motion. So force of A on B, force of B on A. Now if you see here, both the forces are of opposite direction. A is going from this to that side, B is coming in the opposite side. So we can take like here minus negative sign because they are in opposite direction. We know the formula of force F equal to ma. So force of A will be mass of A into acceleration of A, which will be equal to minus mass of B with acceleration of B. If you remember from our first chapter, we got the formula for acceleration. A equal to V minus U by P. This was our formula for acceleration, which we got in the chapter motion. So using the acceleration of A, so acceleration will be V minus U, velocity of A minus initial velocity of A divided by time t. And acceleration of B similarly, final velocity of B minus initial velocity of B divided by the time component. So this is the third one. So after colliding, what will happen? A will also move and B will also move, but finally their velocities will change. So if this is V, A, this will be B. Velocity of A, velocity of B means final velocity of A, final velocity of B. So this one coming, hitting, both are moving together finally. So solving this one, breaking the equation is removing the brackets. If you see here T, both same quantity on either side of the equal. So this and this will get cancelled. So multiplying MA VA minus MA UA is equal to minus of M, this was B, I forgot to write, MB VB minus MB UB. So if you see here, MAVA is mass and final velocity of A, mass and initial velocity of A, mass and final velocity of B, mass and initial velocity of B. So this is our expanded form of the equation. So here this is the component of A, ball means object A, and this is the component of object B. Now what we will do, we will take the initial components, means initial velocity components, and the final velocity components separately. Means initial will be together, final will be together. So if I change those, if I exchange, so I am keeping it here, MAUA, and there will be one minus sign, and this MBUB will come this side, means I am taking all of them together to be plus, sorry, MBUB equal to MAVA will go that side, minus MAVA, and then MBVB minus MBVB. this much. Then I am rubbing the upper part. Now we will remove those minus sign by multiplying the equation with the minus, and we will see what happens afterwards. So finally MA UA plus MB UB equal to, it's not visible, sorry, I didn't saw it. This much, okay. MA UA plus MB UB is equal to MA BA plus MB VB. This is our equation, which is also there in your book. So in this equation, if you see, this is the initial not velocity, sorry, it will be initial momentum. And this is final momentum. We don't do this. So this is how it explains the conservation of momentum. Means the initial momentum is equal to the final momentum of both the objects. Means total initial momentum is equal to total final momentum. You can copy it down. So today only leaving up to here, you note these things down and read the part from page number 122 up to 124 in your book, and if any doubts are there, you can call me. Thank you.